Hi, this is Jeff Spence, your Math 135 instructor, and this is my second calculator tutorial. And this one we'll be talking about how to do the linear regression function in order to compute the correlation coefficient and to figure out the equation of the least squares regression line, also called the best fit line. So this is for problems in section 4.1 and 4.2 to go over the linear regression function in your calculator. So before we do anything, you're going to need to do this once with your calculator, what I'm about to do. And you only need to do it one time. However, if you take out your batteries or clear your memory somehow, you're going to need to do it again every time you clear out your memory. But if you don't ever change out the batteries or don't mess with the memory, you only need to do this once. So everybody needs to do this. I'll make sure this happens in class. You press second 0 to enter the catalog. We need to go down all the way down to diagnostics. So you can scroll down, 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 down until you get to diagnostics. Mine's going to take a little bit here. So scroll down, down, down until you get to D. And you'll see diagnostic on when you get there. So I'm just going to take a while here. Diagnostic on. Pick diagnostic on by pressing enter, and then press enter again to perform it, and it'll say done. So if you have done this on your screen, you only need to do it once unless you take out your batteries. So I'm going to clear the screen, clear my key history. Alright, now in order to do linear regression, you need to have data from a table, two variables. The first thing we always want to do is do a scatter plot. But once we have the scatter plot up, imagine these points that we plotted based on the low temp and the high temp. We want to be able to compute the correlation coefficient, R, and get the equation of the least squares regression line. Our calculator will do both. So what we're going to have to do is enter in this data into our calculator. We always put the x values in the list 1 and our y values in list 2. So if I go back to my list 1, I look at the first few numbers, it's 10, 20, 20, and I go to stat, edit. Now notice I have data in list 1 and list 2, so I got to make sure that I clear it. So I go up to list 2, press clear, enter to clear that one, go over, highlight list 1, press clear, and enter. So I start putting in the data. It was 10, I'm just reading this from the table, 20, 20, let me go back and look, 10, 20, 20, 30, 30, 40, 40, keep putting in the data. I got 40, 40, 50, 50, and 60. Okay, so 50, 50, and then 60. Then I put in the corresponding y values, so I have to go over to list 2, look back at the table, 29, 37, 43, 29, 37, 43, what's the next one, 41, 49, 50, 41, what was it, 49, 50, okay, oops, 58, 64, 70, 58, 64, 70, and then the last one was 74, and then I have all the data values in. One check to make sure that you're going to be on the right track is that you have the same number of data values in list 1 as you do in list 2. If you don't have that, you will get an error when you perform this function. So now that we have all the data values in, alright, it took a little while for me to do it on this emulator, but you'll have all the data values, the predictor or the independent variable, the predictor or independent variable in list 1, the x value, and the response or the dependent variable in list 2. Dependent, independent, dependent. So once we put that in, you go to stat, over to calculate, and you pick the linear regression function. It's the fourth option down. Pick it and make sure that you have list 1 and then list 2. Now, some of your calculators don't show this look. Okay, if you pick the linear regression function and just press enter, then it'll perform the function and give you this output. Okay, now y equals ax plus b is the form of a line, a being the slope and b being the y-intercept. You know, if you remember y equals mx plus b, a is just being, or m is being replaced with a. So a is the slope and b is the y-intercept. Notice we get a slope of 0.9 and a y-intercept of 20. If we look back to the regression line from our earlier lecture, it's the same numbers. Okay, so that's how we get that equation of the best fit line. We talked about interpreting the slope and the y-intercept in that lecture, don't forget that. But that's how you get the equation of the line. You would write out y equals 0.9 times x plus 20. Then we also get the correlation of coefficient down here, r, which is 0.97 if we round that to 2 decimals, which means that there's a very strong linear correlation between the low temp and the high temp of certain cities. R squared here is called the coefficient of determination. We won't be using that in the intro to stats, but it is something that if you go on to a further course you will be talking about. But right now we're just focused on the equation of the best fit line, which is given by the first two lines. It gives you a and b, the slope and the y-intercept, and the correlation coefficient. Once you have those, you can answer all the questions that are asked of you. This calculator function does a lot of complicated formulas for you that were shown on the lecture slides, so you don't need to do that. You just need to remember to go into stat, go into edit, put the x variable in list 1, the independent variable, and the y variable, the dependent response variable in list 2. Go over to stat, calculate, pick linear regression, and make sure you're using the right lists. If your calculator is older and doesn't show you this display right here, all you have to do is press enter once. I have to press enter a few times and it'll give you the results. And that's how you do this function. We'll see you next time.